The planet Neptune is orbited by 16 known moons. These moons are all named after various sea gods and nymphs in Greek mythology. The first moon discovered was Triton, and the second was Nereid. Voyager 2 revealed 6 more moons, and in the years since, 8 more have been discovered. Not much is known about most of the moons of Neptune, as they're very hard to observe from Earth because of how far away they are. It doesn't help that a lot of them are really dark, too. That's not going to stop me from talking about them, though, so come along with me as I tell you about the moons of Neptune. Triton was discovered on October 10th, 1846 by British astronomer William Lassell. This was just 17 days after Neptune itself was discovered. It takes its name from a son of Poseidon, the Greek equivalent to Neptune. With a diameter of 1,680 miles, Triton is Neptune's largest moon and also the only spherical one. It orbits an average of 220,500 miles from Neptune and completes an orbit once every 5.877 days. Locked in synchronous rotation, it only shows one side of itself to Neptune. However, its orbit is inclined by about 157 degrees from Neptune's equator, and the moon itself is tilted on its axis by about 30 degrees. This means its polar regions take turns pointing at Neptune. Another fascinating aspect of Triton's orbit is the fact that it is the only large planet in the solar system that orbits in the retrograde direction. That means it orbits in the direction opposite of Neptune's rotation. This retrograde orbit has led scientists to suspect that Triton may be a Kuiper Belt object that was captured into orbit around Neptune. This idea is supported by the similarities that Triton shares with Pluto, which is perhaps the most well-known Kuiper Belt object. A model in 2006 suggested that Triton may have originally been a member of a binary system orbiting the Sun. During a close encounter with Neptune, the planet pulled Triton away from its companion. Researchers considered this idea again in 2017. They noted that when Neptune's gravity captured Triton, the secondary body managed to escape. In this scenario, Triton likely only survived because Neptune didn't have another large moon at the time. If a large moon existed in a prograde orbit, its gravitational influence would have instead caused Triton to fall into Neptune. That doesn't mean Neptune had no moons at the time, though. In fact, it likely already had a system of moons. This system would have been heavily disrupted when Triton joined. The large moon could have caused previous moons to either shoot into Neptune or just get thrown out of their orbit entirely. Triton features a sparsely cratered surface with smooth volcanic plains, mounds, and round pits formed by icy lava flows. A crust of frozen nitrogen sits atop an icy mantle, and this mantle is thought to surround a core of rock and metal. Triton is about twice as dense as water, and this gives it a higher measured density than almost any other satellite of the giant planets except for Europa and Io, 2 moons of Jupiter. The high density implies that Triton contains more rock in its interior than the icy satellites of Saturn and Uranus. Triton has a thin atmosphere that consists mostly of nitrogen with small amounts of methane, and this atmosphere varies in thickness across its seasons. This atmosphere most likely comes from the moon's volcanic activity that is driven by seasonal heating from the sun. This makes Triton one of only 3 bodies in the solar system, aside from Earth, that are known to be volcanically active in the present time. The other 2 are Venus and Io. Voyager 2 detected surface temperatures as low as negative 391 degrees Fahrenheit. Because of how cold it is, most nitrogen condenses into frost. This gives Triton an icy sheen that reflects 70% of the sunlight that hits it. Because of the moon's retrograde orbit, Neptune's gravity is slowly pulling Triton closer to it. In millions of years, Triton will come close enough to be ripped apart by gravitational forces, and this just might form a ring. Nereid was discovered on May 1st, 1949 by Gerard P. Kuiper. It takes its name from the Nereids, or sea nymphs in Greek mythology. Similarly, all the irregular satellites of Neptune are named after individual Nereids. Nereid was the last Neptunian satellite discovered prior to Voyager 2's visit. Nereid has a diameter of about 210 miles. On average, it orbits about 3.4 million miles from Neptune, but there's a pretty heavy emphasis on average here. Its orbit is highly eccentric. At its closest to Neptune, it's about 858,000 miles away, and at its farthest, the distance increases to a staggering nearly 6 million miles. It takes 360 days to complete one orbit. Nereid's odd orbit could suggest a couple of different things. For one, it could be a captured asteroid or a Kuiper Belt object. Captured moons tend to have very unusual and eccentric orbits, after all. Alternatively, it could have been orbiting Neptune prior to Triton's arrival, and when the large moon came in, Nereid's orbit became extremely disturbed. In August of 1989, Voyager 2 flew past the Neptunian system and discovered 6 more moons. Larissa was initially spotted through ground ground-based telescopes in 1981 by Harold J. Reitsema, William B. Hubbard, Larry A. Lebowski, and David J. Tholen, but it wasn't officially discovered and confirmed until Voyager 2's flyby. It takes its name from a nymph and lover of Poseidon in Greek mythology. Larissa is about 60 miles in diameter, lies an average of 45,700 miles from Neptune, and completes an orbit every 13 hours and 20 minutes. It has an irregular shape and a heavily cratered surface. Its orbit is mostly circular, but it's slowly spiraling inward and will eventually either crash into Neptune's atmosphere or break apart to form a ring. Proteus is about 260 miles in diameter, lies an average of 73,101 miles from Neptune, and orbits once every 27 hours. It's named after a shape-changing sea god in Greek mythology. Proteus was a surprise find among the Voyager discoveries because it's larger than Nereid, which was discovered from Earth. However, it's much darker, and this could be what helped it evade detection through a telescope. Like Saturn's moon Phoebe, it reflects only about 6% of the sunlight that hits it, which makes it one of the darkest objects in the solar system. Proteus has an odd box-like shape. If it had just a little bit more mass, gravity would probably be able to pull it into a sphere. Its surface is heavily cratered and has no signs of geological modification. Naiad was the last moon discovered in the Voyager 2 flyby in September of 1989. Then it sort of went missing and wasn't seen again until 2013. Scientists used a different technique on the Hubble Space Telescope to reduce Neptune's glare, thus making the moon much more visible. It's named after a type of nymph that presided over fountains, wells, springs, streams, and brooks in Greek mythology. Naiad is thought to be made up of fragments of Neptune's previous moons that were smashed up by disturbances caused when Triton entered the system. It probably hasn't been modified by any internal geological processes since its formation. Naiad orbits pretty close to Neptune at an average of only about 30,000 miles away. It completes one circle around the planet every 7 hours and 6 minutes. Its orbit is decaying, so just like Larissa, it will eventually either crash into Neptune or break apart into a ring. Thalassa lies about 31,000 miles from Neptune and completes an orbit every 7 hours and 28 minutes. It's named after the daughter of Aether and Hermir in Greek mythology. Thalassa is also the Greek word for sea. Like Naiad, Thalassa likely formed from fragments of Neptune's original moons. It's unusual for an irregular moon because it's kind of shaped like a disk. Just like Larissa and Naiad, it will one day crash into Neptune or break into a ring. Galatea orbits an average of about 38,000 miles from Neptune and completes an orbit every 10 hours and 18 minutes. It's named after a sea nymph who attended to Poseidon. It was found in the same month that scientists discovered the ring arcs or partial rings that were suspected to exist around Neptune. Galatea's gravity is believed to cause disturbances in Neptune's ring system that prevent these arcs from spreading out. Despina is an average of 32,638 miles from Neptune and completes an orbit every 8 hours. It's named after a daughter of Poseidon and Demeter. At its distance, it's located within Neptune's faint ring system. Since Voyager 2, improvements in telescope technology on Earth have allowed for the discovery of even more Neptunian moons. All of these moons are irregular, so they take their names from the Nereids in Greek mythology. Laomedea, Halimede, and Sao were all discovered in August of 2002 by Matthew J. Holman, John J. Cavallars, Tommy Grav, Wesley C. Fraser, and Dan Milosaljevic. The team used images taken by the 4.0-meter Blanco telescope at the Cerro Tololo Inter-American Observatory in Chile and the 3.6-meter Canada-France-Hawaii telescope in Hawaii. To find the moons, multiple images were digitally combined until stars appeared as streaks and moons appeared as points of light. Laomedea orbits in the prograde direction about 14.7 million miles from Neptune. It completes an orbit about every 3,176 days. Halimede orbits in the retrograde direction about 10.4 million miles from Neptune, completing an orbit every 1,879 days. Sao orbits in the prograde direction about 14 million miles from Neptune every 2,919 days. Neso was technically discovered along with the previous 3 moons, but it wasn't noticed until 2003. It orbits in the retrograde direction about 31.2 million miles from Neptune. It completes an orbit in about 26 years. Psamathe was discovered in August 29, 2003 by Scott S. Shepard, David C. Jewett, and Jan T. Klena using the 8.3-meter Subaru reflector at the Mauna Kea Observatory in Hawaii. It's about 29 million miles from Neptune and completes an orbit in almost 26 years. Hippocamp was discovered on July 1, 2013 by Mark Showalter using images of the Neptunian system taken by the Hubble Space Telescope between 2004 and 2009. Showalter analyzed over 150 archival images of the system. In these, the same white dot appeared over and over again. Using this, he plotted a circular orbit orbit for the moon. Hippocamp is named after a half-horse, half-fish creature in Greek mythology. The same creature is the namesake of the scientific name for the seahorse, Hippocampus. Hippocamp is only 20 miles across and just 65,420 miles from Neptune, completing an orbit every 23 hours. It's unusually close to the moon Proteus. Normally, a moon like Proteus would have swept aside or swallowed a small moon while clearing out its orbit. This means it's likely that Hippocamp is a chipped-off piece of Proteus that resulted from a collision billions of years ago. In February of 2024, 2 new moons of Neptune were announced, right alongside another new moon for Uranus. One is much brighter than the other, and both were first seen in 2021. Scott S. Shepard found the brighter of the 2 moons using the Magellan telescope at the Las Campanas Observatory in Chile. He worked with David Tholen, Chad Trujillo, and Patrick Sofia Laikawa to find the other new moon using the Subaru telescope. Follow-up observations confirmed the brighter moon as orbiting Neptune. The other required special observing time because of how faint it is. The brighter moon has been given the designation S2002N5, and the other is S2021N1. Once S2002N5's orbit was determined, it was traced back to an object that was seen around Neptune in 2003. Back then, though, it disappeared before it could be confirmed as orbiting the planet. S2002N5 is about 14 miles in size and takes almost 9 years to orbit Neptune. S2021N1 is about 8.7 miles in size with an orbit of almost 27 years. This makes it the most distant known moon from its host planet and also the moon with the longest orbital period. S2021N1 has a similar orbit to Psamathe and Neso, while S2002N5 has a similar orbit to Sao and Laomedea. These orbital similarities imply that the groupings may have once been larger moons that broke apart from impacts. Although they only have designations at the moment, they'll eventually receive permanent names based on the Nereid sea goddesses in Greek mythology. And there's the moons of Neptune. There's not very many of them, huh? Well, there's still more than any of the inner terrestrial planets. Seriously, with those guys, we've got Mercury and Venus with none, Earth with 1, and Mars with a staggering 2. The giant planets are hogging all of the moons, and it's just not fair. But anyway, that's about it. We don't know much about Neptune's moons, but they're very far away and hard to see. And nothing has visited Neptune since Voyager 2, who is currently on a one-way trip out of the solar system. I hope you enjoyed learning about Neptune's moons, even if there wasn't a whole lot to learn. Thanks for watching, like, and subscribe if you enjoyed, and have a good day.